Hi, welcome. This is Mr. Chan, and today, well, it's not Wednesday today, but it is Wednesday for you, hopefully today. And we are going to take up some of these word problems that I assigned yesterday. We'll do them together. Okay, so this today's class is really about us getting comfortable with doing these word problems, and then tomorrow you'll be doing them yourself, hopefully. Okay, let's get started with the examples from today. So this first question looks very familiar, or it should look very familiar. We did this today, which is Tuesday, in class, I believe. Now, the two numbers that have a difference of 6, and the product is a minimum. So again, these are all quadratic word problems. So I would like to redirect you to the step-by-step approach to solving them. The most important piece, though, is of course reading the question, finding out what variables and information is given, but also finding out what we need to maximize or minimize. This is a really important point. Okay, because that's the thing we're going to be graphing as a parabola, and then we will find the vertex. Now we have multiple methods of finding the vertex. I want to point that out. So one was to what thing? Uh, GDC slash Desmos, which I'm going to show you some today. Another example that we could do though is using the AOE and sub into function, right? If we can get that axis symmetry, that gives us the x coordinate of the vertex. So all we gotta do is sub it into the function to get the y coordinate. And the x coordinate is not too bad to get from factored form or standard form. And then lastly, we can complete the square. And completing the square requires us to go from standard form to vertex form, right? Standard to vertex. Okay. Over here, we can get AOE from standard or factored, right? I mean, technically, you could also get from the vertex form. It's just H, but that's what we're looking for. Okay, so let's begin. We're looking for two numbers whose difference is 6 and whose product is a minimum. So minimum, that means a quadratic problem. So just like we did today, we're going to define our variables in a very similar method. So we're going to let's let A be the bigger number. And we'll let B be the smaller number. So the first piece of information we're going to get is that the two numbers have a difference of 6, meaning that the bigger number minus the small number should be equal to 6, and the product is a minimum. And again, this product is what we're going to be trying to graph. We're trying to find the minimum of, okay, the vertex of. So let's write out the first equation, which is A minus B is equal to 6, right? And hopefully that makes sense. Um, if we take the bigger number minus small number, it's equal to 6. We can then rearrange this as A is equal to 6 plus B. Rather, the bigger number is equal to the smaller number plus 6. That's another way you can write it. Okay, so that's that. And then we're trying to minimize the area. So we're going to write an equation for the area. So the area is equal to what? Why did I say area? I meant product, sorry. The product, the product is A times B, right? A, B. It's when two numbers are multiplied together. Now we're trying to minimize this, but it's one equation with two variables. So how can I get rid of one of the variables? Hello. We have this piece of information right here that we can sub in. Let's call this 1. Let's call this 2. I'll say sub 1 into 2. So now I'm going to call it P. P. The product is, I'm not going to put brackets because now it looks like a function. P is equal to AB, right? But it's not equal to AB because we're substituting 6 plus B for A. Don't forget the brackets. And then look, we've got this function that we're trying to maximize. Now, we already have this function in a very unique form. Does anyone know what form this is? Well, hopefully you are thinking vertex form. I mean, sorry, factored form. This is not vertex form. This is not vertex form. This is factored form, right? So from this factored form, we know the zeros. And from the zeros, we can find our equation of axis. So if you wanted to, you could expand this, right? And then complete the square and then find the vertex. Or we could just find the midpoint of the zeros to get the x coordinate of the vertex or the b value, and then just sub it back in here to find a. Okay, so you have multiple ways to approach this. You also could graph it. So again, I just talked about all these three. You could again graph it, graph this p, right, and find the minimum. You could find the axis of symmetry from factored form, which I'm going to do right now, or you can complete the square, which I think I want to do as well, just for fun. Just for fun. Okay, so let's start by um, solving. So method one, let's use find EOA. So to find the EOA, what do we need to do? Well, we have 6 plus b times b is our product. So hopefully we can realize that the zeros are at 0 and -6. So if I roughly sketch this beast, right, and let's change font color for fun, 0, -6, right? And we know it's a minimum, therefore it must be opening upwards because there's a minimum, right? It looks like something like this, right? So again, hopefully everyone can see that without even drawing this diagram, you should have seen that the zeros are -6 and 0. Therefore, the EOA is what? Well, of course, it's got to be right in the middle. It's -3. Okay, so EOA is -6 plus 0 divided by 2, which is -6 over 2, which is -3. Okay, and that's our x value. But of course, in this case, we're not looking for x, we're looking for b. And we see that b is equal to -3. Okay. So b is a smaller number, is -3. How do I find the bigger number? Well, sub into this equation, which will give us a, which is 1. So a is equal to 6 plus -3, and a is equal to 3. Okay. So then we see a therefore statement. Therefore, the two numbers, sorry about my handwriting, are 3 and -3. How fun. Okay, let's do the other method just for fun. Let's say we didn't know that we could use factored form to find the EOA. Instead, we're going to complete the square. We'll get straight into vertex form, and then from vertex form, we good, right? So again, all you gotta do is take this equation, our P equation. So P is equal to, what was it? It was 6 plus B times B, which is equal to B squared plus 6B. Okay, in order to complete the square, we got to, I mean, we need to factor the a out, but there's no a here. So all we need to do is divide this by 2 and then square it, and then add and subtract it. So let's do that. B squared plus, so that's a 6, by the way. It looks like BB, but it's 6B. And I'm going to add and subtract. 6 divided by 2 is 3, squared is 9. So add 9, subtract 9, and then what happens? Well, this turns into a sexy perfect square. Okay, so this is B plus 3 squared, and then we subtract 9 at the end. Okay, this is a b. So again, you can see that the vertex is, of course, b is going to be -3, which we found over here, right, in a separate way. But again, you can see b is equal to -3, and then you would sub into 1, and then you'll get a is equal to 3, just like we subbed into 1 over here. Okay, so there's multiple ways of doing this, but the final answer indeed is 3 and -3. Let's move on? Question mark? Yeah, let's move on. Okay, so that's question the first. Question the second, we have 600 meters of fencing and we want to fence off a rectangular lot and then subdivide it into 3 equal rectangular lots. How does one do this, you ask? Well, first of all, we read the question carefully, but we then draw a diagram. So let's draw a diagram. Let's get a fun color. Now, we know it's a rectangular shape like this, and we know it's split off into 3 equal parts. Okay, that was bad. Let me like try drawing that again. Okay, better. And we have 3 equal parts. So here's 3. I mean, they're kind of equal, right? And we have 600 meters of fencing. Now, that's a lot of fencing, right? We need fences for all the sides. What we want to do now is we want to define variables so that we don't have to refer to these sides as just random sides. So let's. I used a and b last time, but my b's look like 6s. So let's use I don't like X and Y. Let's use C and D. Why not? For fun, right? For fun. My C's suck, actually. Mm, L for length. Yeah, I like that. L. We got some L's. And then what would this be called? Maybe D for depth. Okay, D for depth. I don't have to use C. Okay, so we've got a length, we've got the depth, and then obviously this is D, this is D, this is D, and this is L as well, right? This distance. I hope it's obvious at least. Okay, let's get some let statements up in this. Let, I almost wrote A. Let L be the total length of uh the rectangular lot. I could have just said lot. I don't know why I wrote rectangular. Anyways, let's move on. Then we're gonna let D be the depth of rectangular lot. Okay. And again, we've got a picture here, so hopefully it makes sense. Now, we're looking to maximize the area that can be enclosed. So again, that's the first thing you always want to figure out is what are we maximizing or minimizing? Well, we're maximizing the area. So I'm going to say area that is enclosed. Well, again, this entire thing is what we're trying to maximize. So we're really trying to maximize DL, if that makes sense. DL. So DL. Why does that look weird? Anyway, let's not worry about that for now. Okay, so DL. And of course, we're trying to maximize this, but we have two variables. We don't like that. We only want one variable. Good thing we got some extra information that'll give us the other variable. What do we know? We know that there's a total of 600 meters of fencing. Therefore, if we add up all the sides of this fence, then they should add to 1, 2, 3, 4, 5, 6. If we add all this garbage together, that should total to 600 meters. Now, what the heck just happened with the highlighter over there? There's a weird dot. Anyways, let's not worry about it. So now we need to write an equation that sums up all the fence lengths. Let's do that. So let's say fence length. We know the total is equal to 600. And that's going to be equal to, again, 4Ds plus 2Ls. So 4D plus 2L. All right. That's cool. Or is it? Well, we've got this new equation. And we need to isolate one variable so we can substitute it into this equation and then find the vertex of this. That's what we're doing. Now, this over here is quite ugly. What can I do to make this a little nicer? Well, I could divide both sides by 2. What happens if I do that? Well, this turns into 300. That's a 3. Is equal to 2D plus L. Okay. And then we can do what? Well, we can isolate for L. L is equal to 300 minus 2D. Then we can call this 1. We'll call this 2. And we'll say sub 1 into 2. Now our area is equal to what? Well, it's D times L, but instead of L now, we're going to have 300 minus 2D. 300 minus 2D. And again, we're trying to find the maximum. So hopefully this is a downward slope, or not sloping, a downwards opening parabola, and it is, right? The D squared value has an A value of minus 2. Now, if you want, you could expand it and write that out as minus 2D squared plus 300D, and there you can very clearly see that it's opening down. But the reason why I like this form is because it's in factored form. Actually, it's not quite in factored form, but it's almost in factored form. Okay. And from factored form, we can then find the EOA, as we did earlier. We had factored form, found the EOA, and then substitute that into the equation. I'm actually going to complete the square for this one, because as I mentioned in class, I like completing the square more. But you could definitely find that, 0 and D is 150 is the other 0, so it should be 75. But again, let's not worry about that for now. Okay, so if I'm going to complete the square, this is going to be equal to what? This is equal to minus 2 D. Okay, I regret completing the square now, but that's okay. D squared minus 150? Yes, right? D. Okay, I really regret completing the square now. I'll show you how to do this without completing the square. We'll use factored form because this is turning ugly, but I'm going to still do it because I've committed. I've already committed. So I need to take this minus 150 divide by 2 and then square it. That's minus 150 divide by 2 is minus 75. And then 75 squared is, I don't even know. 75 times 75 is 5625. Okay, so again, I already have lots of regrets for completing the square, but it's still doable. So I'm going to add and subtract this beast. What beast? Well, I just found it. It's 5625. 5625 minus 5625. Okay, so now what? Well, now we know that this first 3 terms turns into a perfect square. And yeah, It's not that obvious, but it's 75. It's d minus 75 squared. And then, of course, we have to remove this from the minus 2. So we're going to add minus times minus. What's 5625 times 2? Can I just write times 2? No, but I can write answer times 2. 11, 11250. Okay. So this was not the best way to find it, but again, now that we know the vertex, right, our d is going to be equal to 75. So this is 75, right? 75, 75, 75. And then in order for us to find L, all we got to do is sub it back into thing. So from here, we can see d is equal to 75. That's the vertex, right? That's at least the x-coordinate of the vertex. The y-coordinate is 11250, which of course is the area of the entire thing, which we have for B, which is nice. Let's find L though first. So L is equal to 300 minus 2 times D. We said it was 75. So it's going to be 300 minus, what the heck, 75 times 2 is 150. So it's equal to 150. Okay. So this is 150, this is 150, and these are all 75, right? Now, as I mentioned, I wanted to also show you how I could solve for d is equal to 75 by using the factor method, aka finding the midpoint between the two zeros. And I'm going to do it over here. So we had the area is equal to d times 300 minus 2d. I'm just going to rearrange this, and I'm going to factor out a minus 2d. No, minus 2 from this beast over here. So this just turns into minus 2d. And then we'll also have d. No. Yes, d minus 150. Yep. Let me rewrite that. That's ugly as sin. 150. Okay. And hopefully everyone sees how I went from here to here. I just factored out a minus 2. And then what's left over? Well, again, we just need to, whoops, what did I press? We needed to find the zeros. From here, hopefully you can see the zeros are when a is 0, either d is 0 or d is equal to 150. And again, we know that this is looking like this, right? We got 0 here, we got 150 here. You definitely don't need to draw this diagram every time. I'm just trying to demonstrate the equation of axis, right? And is this opening up or down? Well, it's opening down, right? It's minus 2d squared, right? The minus is on the outside, so it's opening down. It is a maximum, of course, and it's gonna look something like this. And of course, now we can confirm that the midpoint is indeed 75, okay? Which is our answer from here. Okay. Oh gosh, I hope that wasn't too confusing. Anyways, we're not even done the question yet. We just found out what D and L are, which was the very first question. So what's the, never mind. We found out the, the answer to the second question. What dimensions will give the maximum area? Well, we know that we have D is 75. Can we highlight this? It's getting a little messy here. D is 75 and L is 150. Okay. So the dimensions are 75 feet. Is it feet? Meters. 75 meters by 150 meters. Okay. What dimensions will give this? Oh, sorry, I answered this in the wrong place. Yes, those are the dimensions. What's the area going to be? Well, all you gotta do is 75 times 150. We also got the answer over here when we did vertex form, right? Because this is the vertex. The vertex is representing the x-coordinate, which is d, and then of course the y-coordinate is area. So it should be 12, 11250. But let's double check for fun. So we're gonna multiply. What did I say the dimensions were? 75 by 150. And we get the same answer. Okay, life is good. Life is good. So the answer for this first one is just 11250, and technically it's in meters squared. And then finally, what's the area of each individual field? What individual field are you talking about? Well, there's 3, right? There's 3, 1, 2, and 3, right? We wanted 3 subdivided fields, or we wanted the field to be subdivided into 3. So at this point, all we gotta do is take the total area, which we found in the first answer, divided by 3, and then we'll get each of the individual fields. So the final answer for this is gonna be 11250 divided by 3. Let's do that in our calculatrice. Answer divided by 3 gives us 3750. 3750. Okay. And technically this isn't meters squared, right? Because we're looking at an area. And then we're done. How do we feel about that? Hopefully good, because I can't hear you. Let's move on. Let's move on. This is a very common type of question as well. There's a theater, a ballet, some sort of event or concert, and we charge people for the tickets, of course, right? Now we start off with a base number of people and a base price for the ticket, and then we try to micro adjust to find the optimum level. Okay, so let's read the question very carefully. There's a theater can seat 200 people and charges $10 for a ticket. That's the baseline. Okay, at this price, all the tickets will be sold. Now they have a survey that indicates if the ticket price is increased, the number of tickets sold will decrease by 10 for every time the price is increased by $1. Every dollar increase. So now we're looking for what ticket price would result in the greatest revenue. Okay. Well, this is confusing. The first thing we need to figure out is what are we trying to maximize or minimize? And the answer is greatest revenue. So we're trying to maximize revenue. Now, what's revenue equal to? And this is an economics sort of thing. Revenue is equal to price times quantity. Okay. So what ticket price would maximize price times quantity? Well, we need to define price and quantity a little more carefully. Now, normally, how many tickets do we sell? We sell 200. And normally, how much do we charge? We charge $10, right? So 10 times 200. That's our baseline. But what happens if we reduce our ticket prices, or sorry, increase our ticket prices by $1? Well, then we have 190 people attend, and it's going to be $11, right? So the way we do this kinds of question is we let X be the number of ticket price increases. Let X be the number of ticket price increases. And I should even be more specific. I should say number of ticket price increases, and I'll say by $1 each. So each time we increase the price, it'll be by $1. Okay, so if X is 1, we increase the price to $11, $1 more. If X is 2, it's $12. If X is minus 1, it's $9. Okay, so now that we've defined X as the number of ticket price increases, we can now define our revenue. Our revenue is going to be equal to what? Well, normally it was price times quantity, right? And normally it was $10 per ticket times 200. But now we've got X involved. What does X do? Well, X says that if we increase the price by $1, what's going on? So now instead of charging $10, we're going to charge 10 plus X. If the price increased once, then the price would then be $11, $1 increase. If X was 5, that would be the price is $15, or 5 $1 increases. Okay, so we got the price. This kind of multiplied by the quantity. What's the quantity? Well, normally it's 200, but now every single time we increase the price by $1, we lose out on what? We lose out on 10 seats for every dollar increase. So X is the number of dollar increases. So I'm going to just subtract this by 10X. So again, if X was 1, what does that mean? That means that movie prices are $11 and we only sell 190 seats, as I indicated earlier. Okay. And then this 11 times 190 would be our total revenue. If X was 2, I would charge $12 and I would lose 20 seats. So I'd only have 180. And then this is my total revenue, 12 times 180. So the question is, when do I maximize this? Okay. Now let's take a look at this equation. We want to maximize this. So first of all, when we expand it, we would hope that the A value is going to be negative because that's a maximum, right? For starters. But in order for us to find that the vertex, we can use this form. What form is this, by the way? This is indeed factored form. It just doesn't look like it. We got to rearrange some stuff. So first of all, let's get the x in the front because I don't like x's in the back. Same thing over here, minus 10x plus 200. And then I'm going to factor a minus 1 out of this beast. So this will be minus x plus 10. Actually, I should have factored a minus 10, sorry. So minus 10 out of that beast. What's left over? We have an x plus 20, right? Is that right? Why does this look wrong? Because when I factored it out, this should have been a negative 20. Sorry, I factored a negative out. So negative 10 times negative 20 is then positive 200. Okay, that's looking a lot better. Okay, so now we've got the revenue equation in factored form, we can then find our zeros. What are the zeros? Well, again, hopefully you see them. X is equal to minus 10 or 20, right? And again, using these zeros, we can find the axis of symmetry, and from the axis of symmetry, we can then solve. If you wanted to, you could have expanded this and completed the square. But again, since it's already in factored form for us right here, I think it's way easier to just use the EOA right now. Okay, so let's draw this out very roughly. We got, I don't know, 10, 20, this minus 10 is over here, right? And we've got our zeros at minus 10 and 20. So like this. So what the heck is this value over here? Well, I think I already have it, right? It's minus 10 plus, oh, actually, it's wrong. It's wrong. So you say it's 20 over there. But what is the midpoint over here? How do I find this midpoint? It's not 10. It's not 10. We have to add minus 10 plus 20 to find the midpoint and then divide by 2, right? So this total distance over here, of course, is 10 here and 20 here. So it's distance of 30. So it should be in 15 as the midpoint, right? So I should subtract 15 from 20 or add 15 to minus 10, which would be 5. Let's double check that though. So again, let us find the EOA. EOA is x is equal to minus 10 plus 20 divided by 2, which is 10 divided by 2, which is 5. Okay, which is good. All right. So the equation of x is 5. What the heck does that mean? That means x is equal to 5, right? Now, I don't know if you guys noticed this, but I just did. But this parabola is not supposed to open up. It's supposed to open down because we're looking for a maximum. My bad. My bad. So, blah, 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 blah. And this over here is 5. We just found that, right? Okay. So we know the x coordinate is 5. We just got to find the y coordinate. But if you take a look at the question, it says what ticket price would result in the greatest revenue. We don't even need to find what the revenue is. We don't need to find this value of y. All we need to do is find out how many ticket price increases we need, and we already found that it's 5. So when it says what ticket price would result in the greatest revenue, we have 5 ticket increases. It started at $10 a ticket, and we did 5 $1 increases. Therefore, ticket price will be $15. Okay. So therefore, the ticket price uh, is $15. And that would result in the greatest revenue. Okay. Are you having fun? I hope so. Let's move on. Miss Evans loves softball, but every time she hits the ball, it's a pop fly. What the heck is a pop fly? The height h of the ball in meters is given by this equation, where t is in seconds. What is the maximum height of the ball if it is caught at the same height at which it was hit? Ooh, I like this question. If it is caught at the same height at which it was hit, how long is it in the air? Okay, cool. Let's do the first one first. So this, I'm gonna graph this because ain't nobody got time. Again, this one is quite simple I mean, relatively speaking, because there's an equation for you. The other ones we had to find the equations ourselves, right? Okay, let's take a gander at Desmos. So how do I do this? Maybe I'll do Desmos over here. Desmos graphing calculatrice. Oh, this is probably not a great place for Desmos, but whatever. 1.2 plus 20x minus 5x squared is the equation. Oh, here's what it looks like. How nice, how nice. And what's the maximum height of the ball? Okay, so again, for this, we can just click on the vertex and we can see the maximum height is 21.2. What is it? Meters? Meters after 2, was it seconds, right? So I'm going to say A from Desmos. Again, the equation was just given to us, so no point in completing the square there. Or you could, but I didn't like that decimal. Okay, anyways, from Desmos, we know the vertex is 2 and 21.2. 2 and 21 point, I almost wrote 5.2. So what is the maximum height of the ball? The maximum height is 21.2 meters. Right. Okay, cool. And then if the ball is caught at the same height at which it was hit, how long is the ball in the air? Okay, this one's a little bit tricky. I'm going to use Desmos to try to explain this though. Okay. So first of all, where was the ball, or what height was the ball hit? Well, that hopefully you know is at time 0 seconds. So at 0 seconds, that's when the ball was hit, and we have an initial height of 1.2. So it's asking if the ball is caught at the same height. If it's caught at 1.2, how long was it? So what I can do is actually I can add a y is equal to 1.2, and I can see very clearly that for the duration of this blue line, this is the distance. Okay. So again, you can see here that it was so it's 0 seconds and 4 seconds, so it was 4 seconds. Um, and hopefully that makes sense. If you didn't know that, you didn't know how to do this, all you'd have to do is sub it into your equation, right? So the first thing I would do is I would say for B, I would say, what height was it when it was first hit? Well, again, all you have to do is find at t 0, 0, so at time 0, that was when it was first hit. This turns into 0, this turns into 0, and of course the height is just going to be 1.2. H is equal to 1.2. So then we're like, okay, if it was hit at 1.2 in terms of the height, when does it come back to 1.2? So all you got to do for that is you got to set the equation equal to 1.2. It's your y-axis, right? 1.2 plus 20t minus 5t squared. Oh, how nice, they cancel out. So they cancel out, minus 1.2 on both sides. You get 20t minus 5. Oh my gosh, this got really easy. I guess I didn't even need to use my Desmos for this. This is 0 is equal, I should have my this implies then signs. This means that 0 is equal to 20. I need a factor to minus 5t. So what I have left over, I have t minus 4. Does that look right? Yeah, it does, I think. Okay. And then again, we're trying to solve for what value of t makes this 0, right? So either t is equal to 0 or t is equal to 4. And we got the same answer of 4 right here as we do over here, right? 4. So hopefully everyone sees that. So I can say therefore, my therefore statement, it was in the air for 4 seconds. Again, for it to start at 1.2, which is when it was hit, and then for it to go back to 1.2. Now, of course, it hits the ground over here, right, at 4 and 0.059 extra seconds, but it's not asking for when it hits the ground. It's asking for when it goes down to the original height of 4 or of 1.2. Okay. How are we feeling about that one? Good? Good? Yes, yes. Okay, great. Let's move on to question 5. Oh, okay. Another one of these two integers whose sum is 96 and product is 1728. So this one's interesting. This one doesn't even have a max or a min. So we just have two equations and two unknowns. What are you talking about, Chan? Let's do this. Let x and y be numbers. We know x plus y, the sum of the two numbers is 96. And we know the product, x times y, is 1728, right? So again, here there's no maximization or minimization. We're just literally trying to solve these two equations, and there's two unknowns. So the way we do this is what? Well, again, hopefully you can see, we just need to isolate for x or y and then substitute that into 2. Okay, I guess this is just a question on creating the equations. So from 1, let's say, from 1, we have x plus y is equal to 96. Let's isolate x for fun. 96 minus y. We'll sub into, actually, you know what? I want to call this 3 because we're going to use this later, I think. Sub 3 into 2, which is now the product. So the product is xy, and now it's equal to 96 minus y times y. And again, we have our sexy equation again, right? This is the equation where we have minus y squared plus 96y. Okay. Okay, at this point, you're like, what do I need to do to solve? Well, again, we're trying to find out what x and y are. The way we do this is that we need to set everything to one side. Now, we know the product is 1728, so we probably should insert that somewhere. So xy is equal to 1728. Sorry, I probably should have put that like at the very beginning. Oh, I did. Okay, any hoozle. So we substituted our y in. We know this is equal to 1728. So now this is just a regular quadratic, right? So let's put this in another line. I have minus y squared plus 96y minus 1728 is equal to 0, right? And then we go to solve. For this one, I would like to use my graphing calculatrice. Now, I think it's still doable if you wanted to, but do you really want to? I don't. Okay, so let's graph this. This is minus x squared plus 96x minus 1728. So, oops, 1728. So this is long gone. Oh, there's a line. Oh, there's another line. Okay, so it looks like, okay, good. So we need, so clearly it's opening downwards. Is it? Yeah, it is because it's minus x squared. So I just need to like get the vertex in the picture, kind of. Although I really don't need the vertex because I'm actually solving for the zeros here, right? But I could look for the vertex if I wanted to. In fact, I will just for fun. Let's go up to, I don't know, 2000. Okay, that was a little too high, but I found the vertex. But we're not looking for the vertex, right? We're looking for the zeros that make this true. And the zeros are 24 and 72. From Desmos, uh, y equals 24 or 72. That's interesting. So if y is 24, what is x? That's why I left this over here. Is 92 minus 20, or sorry, 96 minus 24. Let's go back to this calculator. So this is 96 minus 24, 72. Again, I'm over here, by the way, at step 3. And I'm subbing in my y value of 24, and my x will be equal to 72. Okay, and if you do the other way, you'll get x is equal to 24. So it doesn't really matter which the numbers are, if which one's x, which one's y, but the two numbers are 24 and 72. Okay, so I'll say therefore the two numbers are 24 and 72. Okay, let's move on. Hopefully everyone is happy. Are you happy? I hope so. Okay, the last question, question 6. What the heck is this one about? So this one is about Chris cutting a lawn 40 by 30 and most strips equal to the width around the perimeter. Louis, I don't know how to pronounce that, cuts the small rectangle left. How wide a strip does Chris cut so they share the work equally? Oh dear. Oh dear. So let me just think about this. Chris cuts half a rectangular lawn, but Moen strips equal to the width around the perimeter. Lou cuts a small rectangle. Oh, I see. Okay. So when Chris mows strips around the perimeter, essentially that's like making a little path. Okay, let's just draw this out. So this is 40 by 30, so something like this. This is 30, this is 40. Why did I write X there? I don't know. Meters is what I meant to write. Okay, and then Chris starts cutting the lawn by cutting around the perimeter. So, and it's an equal around the perimeter. So Chris basically cuts all of the. Okay, that's not equal. Like that. Okay, that's the best I'm gonna get done. Okay, so this is Chris. All Chris cutting the outside of the rectangular lawn. So this is Chris, and then we have I don't know how to pronounce. Oh, that's a horrible color. I'm sorry. Louis, Lou. Lou cuts the middle part over here. Okay. So that's what this question is basically saying. So again, it's a 40 by 30 lawn. Chris cuts around equally around the perimeter, and then Lou cuts the small rectangle left, the rectangle in the middle. And the question is, how wide does the strip need to be so that they share the work equally? How wide? So we're gonna need. Okay. So first of all, this pink is in the way. It's very distracting as well. Maybe I can. Maybe I can shade it in pink instead. You know what I mean? It's also distracting, but it's not as bad. Okay, the key that I want to draw though is that I want you to see that this is X. Okay, so that's the width of the path. And of course, we're trying to find out what the width is going to be in order for Chris and Louis to cut the same amount of lawn. They want to share their work equally. Okay, so first of all, we actually have some information about the total area which is what? Well, it's 30 times 40, right? That's the total area of this land. Now, if that's the total area, then what's 30 times 40? Is that 1200? I think it is, but canon mental math. Okay, 1200. Okay. So if the total area is 1200 and they're going to split it equally, how much land should Chris and Louis be mowing? And the answer is, of course, 600. It's a half of 1200. So this is the entire lawn. And then, of course, since we want them to share the work equally, that would mean that each Louis, is that how you spell it? And Chris cut 600 meters squared, right? I should really have put those in meters squared. This is meters, this is meters. Okay, anyways, let's move on. Okay. Now, I need to define another variable. No, I don't. I need to define my first variable, which I never did. Let x be the width of the strip, right? These going strips in meters. All right. Great. Now I've got our let statement. I know how much lawn they need to mow. Let's see if I can solve for how much lawn they need to mow each. Now, each of them is going to be doing 600. So how would I go about creating an equation that um, accounts for both Chris and Louis? So the first thing we need to consider is how much land is in the middle. This is a total of 600 meters squared, right? And that pink area on the outside is also 600 meters squared. So let's create some equations to see what we can do. So first of all, Louis' plot of land, which is in the middle, what are the dimensions of it? Well, we don't really know, right? But we have it in terms of variables. We know that this total distance is 40. And I said take off an x and take off another x, we'll get this height, right? And then similarly, if we take 30, which is this length, subtract an x and subtract another x, we'll get this distance. And then we multiply those two together, it should be equal to 600. Okay. So this is from Louis' perspective. And you could have done it from Chris's. But let's start with Louis. So from Louis' part, we know that the interior area is equal to 600, which is equal to 30 minus 2x times 40 minus 2x. And that's going to be equal to 600. Okay. Now what? Well, now we need to solve for x. And again, this is not that fun. Why? Because I'm not trying to find a zero anymore. I'm not trying to find a factored form, because again, it's all equal to 600. I need to expand this first and then factor it, or put it into Desmos, which I'm probably going to do. Okay, so let's expand it. So again, we know 600 is equal to, what's 30 times 40? I think I did that, 1200, right? Then 30 times 2x is minus 60x. Then 40 times 2x is minus 80x. And then I've got minus 2x times minus 2x is plus 4x squared. Then let's move that 600 to the other side. So 0, now it's 0, is equal to 600 minus 140x plus 4x squared. Can we rewrite this? Because I find it ugly to have the 600 over there, even though I think I've done it in a couple other questions. There we go. Okay, and at this point, now you plop it into Desmos. You also could complete the square if you wanted to, or not complete the square, sorry, solve if you wanted to by factoring, but that's what we're looking for. And again, I want to emphasize that again, we are not looking for the maximum or minimum at this point. We're looking for the 0, right? That's equal to 0. We did the same thing with another question earlier, right? It's equal to 0. We're not looking for a maximum or a min. So be mindful of that. Same with this one. Okay. But for the other ones, we are looking for 0. So once we found the zeros, we are looking for the vertex. Once we found the zeros, we had to then put it into the midpoint method to find the EOA, and once we had the EOA, we then got the vertex. Okay, so just be mindful of some questions are asking for the vertex, other questions are asking for the zeros. And it really depends on what the question is asking. In this specific scenario, you can see we're looking for zeros. Okay, so what are they? I don't know. We have to graph it. So let's go to thing. What thing? Desmos. We'll graph. What is this? 4x squared. 3. 4x squared minus 140x plus 600. You got this beast. And again, we're looking for the zeros. So it's 5 and 30. So we say x is equal to 5 or x is equal to 30. Now, 30 is immediately wrong. Why? Does anyone see why? What happens if the width that passes 30 meters? This distance over here is already 30. So it makes no sense for this width to be 30. Okay. In fact, there should be a restriction on x. X has to be less than 15, right? Because again, if there's a path on both sides, the maximum it could be is 15. Any whoozle, the point is x is equal to 5. Okay. So what did we just find out? We just found out that the width of the strip needs to be 5 meters. So we can say, therefore, the width of the strip is 5 meters. Okay. All right. So again, this is solving quadratics, right? We're trying to set them equal to a certain value, like 600, or something equal to a certain value, like 1728, or something equal to a certain value, like 1.2. And then we need to throw everything to one side and factor and solve. Or you might get another question where it just gives you a parabola and it's saying find the max and the min. And from there, you would need to either use one of these strategies, right? GDC, AOE, or completing the square. All right. I think that's all I wanted to cover. And I'm hoping that was helpful for you. If it wasn't, I encourage you to, you can leave a comment in this video and I'll try to get back to you, or you can send me an email. Okay. Um, yeah, I'm done. Have a nice day and I will talk to you in the future. Goodbye. How do I hang up? It's over here. Goodbye.